full screen. OK, so yeah, as was said, this is going to be a talk about WebAssembly, although I'm not actually going to go into a lot of detail about how WebAssembly is written, because I don't want to bore you, but I will show you a little bit of code, so be prepared. I think this might be some of the first code in a 30-minute talk, so let's get ready. First of all, a little bit about me. I currently work at a company called Voxray Games. It's just 5 of us. The founder is Dutch. He was actually the creator of the Cube engine. Very, very cool guy, Wouter van Ortmersen. Before that, I was at Figma, Google, and a number of other game companies. The reason I wanted to mention this is because at Google, I worked a lot on WebAssembly. In fact, I was around when WebAssembly was started in around 2015. And then in 2018, I was the chair of the WebAssembly working group. So I had a lot of involvement in the WebAssembly project. But again, this is not really about any of that. One thing I did want to show was a shot from our current game, just because, you know, if you're on stage, you might as well show off the things that you're working on. If you're a startup, how else are you going to get people to pay attention? Anyway, it's a voxel-based game where you run around. It's kind of Minecraft meets first-person shooter. So what is this talk actually about? It's about WebAssembly. WebAssembly is a virtual instruction set architecture, ISA. You could think of it as a bytecode, like Java bytecode. And it's designed to be a compilation target. So taking your C++ code, your Rust code, your Go code, your Java code, very recently your Kotlin code, a lot of different languages support WebAssembly. What is raw WebAssembly? This is what I call writing WebAssembly without a compiler. So instead of actually compiling from C++, you just write the assembly code directly. What are the raw WebAssembly demos? Well, this is like making demo scene demos. That's kind of what I think of it as. Making something fun, something playful, something joyful. And then tiny. I loved the talk about code golf because this is what my entire talk is about. Every single one of the demos I'm going to show you is less than 4,096 bytes of WebAssembly. And in fact, each one is in less than 3,100 bytes, I believe. So we'll get to see some of those. So for this talk, I'm going to talk about some of the demos from my page, not all of them. And we'll see how much time I have. As always, the clock is always fighting against you. So really, this talk is kind of, I don't know, we'll see, we'll see what we can take away from it. But a lot of this is just, look at some cool stuff that I made. All right, so starting off in 2019, I was very bright-eyed, but I was also a little bit burnt out. I'd been working at Google for 9 years at that point. I'd been in WebAssembly for a while. I was running a lot of the WebAssembly standards meetings, and they were pretty tough. It's tough to sort of organize a new language that has a standard like that. Earlier in the year, in 2019, I was a part of a program that Google ran called Googler in Residence, where you get to go to a historically black college or university and teach there. And so I think at this point in time in this picture, I had just been accepted into that program. I was sort of winding down on all my projects, and I was like, OK, what am I going to do for fun before I go and teach these kids? So that's just to give you a little bit of context where I was when I first started this project. So in May of 2019, I made this Doomfire demo. As you can see, it's 398, well, you can't see it from here, but it's 398 bytes. It creates this kind of cool little effect, and we'll talk about it a little bit. So this is actually based on an effect described by Fabian Sanglard. And it was a port of an effect made for the Doom for PlayStation. So when the Doom logo comes up, there's this kind of cool, fiery effect that shows up in the background. So a little bit about what WebAssembly is like when you write it in text format. As you can see here, this is the top of the WAT file. And yes, we do call it WAT because of the WAT talk. WAT stands for WebAssembly text, and that is the official file name for WebAssembly, text format. So some of the things that make writing WebAssembly text format hard: there are no macros, there are no defines. So instead what you do is you leave comments for yourself so you don't get confused. So you can see here I'm describing the size of the screen, the canvas, the number of pixels there, and then also this -1 just so that I can keep track of that later. Often what you'll see in these demos is that I'll import functions that you don't have in WebAssembly from JavaScript. So in this case, I'm importing random so that I can get a random number, so that I can create some of the effects there. So this is cheating a little bit. Obviously, I could write my own random function in WebAssembly, but you know, it's all for fun, so we can cheat when we want. Also, WebAssembly doesn't actually, the text format doesn't have a way to specify memory addresses. If you were writing in a normal assembly language, often what you would do is you would be able to assign a variable name and say this is where it's located in memory. If anybody here has written 6502 or x86 assembly or any other assembly languages, is very, very common. Here, you can't do that. So what I do is I just make a little memory map and I keep it in my head for when I'm working on these programs. There's also originally no way to specify data without writing it as a binary string. So often what I would do was say, this is where I want to put a bunch of data, and then you write it out as a string, and then these are all the hex codes. So this is the palette data for the Doomfire effect. Later on, there actually is a way to specify that these are all I32 values to make it a little bit easier to write. But again, this just to show you that writing WebAssembly text format is difficult, but rewarding. So this is an example a little bit about what some WebAssembly text code would look like. This is actually a for loop, starting off at 320 and looping down. This is actually setting the row of white pixels at the bottom of the screen. So if I scroll back up to the demo here, one of the cool things about having this all in the web is that I can show you the demos live. But you can see this white strip at the bottom here. That's what this code is doing. So let's go back to that. Oops. So at the top, what we do is we set the variable I to 320. You can see it's quite verbose to do something like this. And then we have an instruction brIf. This is a conditional branch. What that does is it branches back to the top of the loop. If you don't branch to the top of the loop, then you just fall off the end. A loop statement is essentially just a label that says, this is where I want you to branch if you branch to it. So this is a very common technique that you use in a lot of assembly languages. Instead of looping up, you actually loop down to save space. And then there's an additional instruction called local t. What that does is it allows you to write a variable to the local, write a value to the local variable, but then also use it again in the statement. So that saves a little bit of space. It's all about saving those bytes. Very, very important. But of course, if you loop from 320 down to 0 and you don't hit 0, then you have an off by 1 bug that might creep up. So now you can actually offset everything down by 1 to be able to, again, save a few little bytes. So a lot of what writing these demos is about is going through and trying to just optimize these little cases to try and save a little space. And so then finally, WebAssembly does change over time. So at some point, the bulk memory extension was added to WebAssembly. I actually worked on this a little bit. And so you could turn this whole loop into a single instruction memory.fill. But we didn't have this at the time, so I wrote it the long way. So just to give you an example of what this code looks like, the final binary that's produced is 398 bytes, but as you can see, the code to generate that is quite a bit longer and more verbose. So this is a lot of what it looks like to write this code. It kind of looks like Lisp if there's any Lisp hackers, but you don't get to do any of the nice things in Lisp. Everything is very, very low level. You can see like I32 store, that is literally writing a 32-bit value into memory. So yes, you have to do everything the hard way. So the very first demo that I made here, I actually sent out a tweet. I didn't even put in an image because it was just kind of a little fun thing to do. Got a few likes, not a huge number, but you know, Twitter. You can't, don't judge your productivity by what Twitter thinks. Okay, so moving on. So that last one I did in May. This one I did just a week later. This is a little meta ball effect. If you've ever seen, you probably have seen something like this before. I'm not going to go into too much detail about it because we don't have a lot of time, but the basic idea is that you have a point that's bouncing around inside of the square, and then you judge the distance between those points, and then that creates this kind of effect. You sort of look and see which points are closest, and then if you're close enough to a point, you can create a nice, cool lava lamp effect. And again, this one is also quite small. After that, a couple weeks later, I made a ray tracer. This one was actually based on the tiny ray tracer code base. This one's a lot bigger. You can see a whole 1,400 bytes for 4 spheres and shadows and reflections. One of the cool things that I did with this one is, if I can find my mouse, you can actually take some of these things and sort of mess with them and see how it changes where the spheres go. A lot of what happens here is that you just shoot a ray, you follow the ray, and then you draw the pixels. So one of the things that you see in a lot of these demos is that I'm just looping over all the pixels in the canvas and then doing some effect to it. So in a lot of ways, it's like writing a shader. If you've ever done shader demos, it's very, very similar. Okay, so then like a month or so later, I decided to make a game, because you know what? Little toys are fun, but they're not super engaging. What I wanted to do was make something fun for my coworkers. And so this was like a little snake game. You can see it actually has a little title screen where the snake goes around in a circle. This is actually a fun little trick where it just is pretending as though you're holding down the left button, and that makes it go in a little circle. So I'll play it really quick. You can sort of see as you steer around. I actually don't know where, the food is at the bottom here. All right, I'm not going to play this too long. Yeah, and so you can see when I grab the food, it shakes. One thing that people complained about a lot was that if you do this, you run into the score, and that will kill you. People were like, you realize that kills you, right? And I was like, yeah, don't run into the score. So yeah, 1,976 bytes. I'll go into a little bit of detail about this one. So let's see. I have to get focus back out. So this one uses quite a few functions. I've written these as JavaScript just to save you the pain of looking at the very verbose text here. So let's talk about a few of them. Line just draws the line. It draws the border of the play field. Digit and score draw the actual the score into memory. And then string is the thing that actually draws the string on the screen using the memory that was stored there. So you can give it a color and so on. And then blit is kind of the magic of this one. A couple of my demos do this, where you draw and you check for collision at the same time. So what happens is you can draw the eyes of the snake, and then you check to see if those eyes hit a certain color. And that's how you determine whether or not you've collided with the score, for example. So yeah, so this goes into a little bit of detail about that. You can see that there's actually a number of different palette colors here. And the trick that I used was that the palette index is used to determine whether or not it's collision. So you can see that if the 1 bit is set, it's a little hard to see here, but if the 0th bit is set, that's considered to be collision. So the snake and the wall are a collision, but if it's not set, then it's not. So the snake head is not collidable, and neither is a dead snake or food or so on. But the 3rd bit is set if you can eat it. like food, so that's why it's set to 8. So lots of fun little bit tricks like this. Oh yeah, well, and I go into detail about that here. Yeah, so then if bit 3 is set, then it's food. And yeah, so you can see that the snake head is actually drawn in a different color than the snake body. And that's because I'm actually layering the body, and then I draw the snake head on top of that. And I don't want that to instantly kill you, because that would make for a not very fun game. So after that, later in the year, I made a little maze demo. This, for the longest time, was my most popular demo. You can run around in a maze that's automatically generated. The textures are also stored in the file. Hopefully people aren't getting too sick by watching this. Okay, I don't know how to get out of here. Okay, well, you know, I'm sure the maze is completable. We'll just assume that someone could actually figure that out. And there's a little timer up there that keeps track of your best time. So yeah, like I said, this is my most popular demo. I think it still is, right? 500 likes. Again, not a huge number, but you know, it's all about fun, right? I actually ended up doing multiple write-ups about this one. So if you're curious, you should take a look at this link. I won't go into too many details here, but for lack of time. But if you follow these, a lot of the things that's cool about these blog posts is there's a lot of interactable elements, so you can sort of see the WebAssembly and how it changes over time as I make changes to it. And I go into a lot more detail about the WebAssembly that you actually have to write to do that. Okay, so moving on, 2020. So in 2020, I actually didn't make a lot of demos. At this point, I had a really great 2019. I taught the kids. I was ready to. I got my promotion at my job. I was managing now, and I was ready to be a proper software engineer. But I just got super burned out, and the only demo that I was actually able to make was this one, which is the Chrome Dino game. Which fortunately actually is exactly 2020 bytes. So you can see, one person actually said, I didn't realize you could duck in the Dino game. No, it's in the real one too. I took it from the real one. Okay, so yes, this one is in 2020 bytes. What's really cool is someone actually ported this to PyBadge. The Wasm 3 author did this, which I thought was really cool. So the way I made this was that I downloaded all the pictures from the Chrome implementation. You can actually find this in the Chrome source codes. And then I converted those into 1-bit per pixel graphics. And then, of course, I realized that that was going to be way too big. It would completely blow out my 4,000 byte limit. So then I implemented a compression algorithm, which this is actually the comments from the code about how it works so that I could actually remember how it works. But ultimately, it ends up making a nice, tiny amount of code to compress all of these graphics. And you can see, yeah, it reduced it from 6,600 bytes, too big, way too big, to 491, much better. And like Snake, this one actually uses the blit function to determine whether or not you collide. So this way, you do collide with the cactus, but you don't collide with, say, the clouds in the background there, because no, you can't collide with the clouds. Those are way far away. Okay, so 2021. So like I said, I was completely burnt out by then, by the end of 2020. 2021, I took a year off. I didn't work at all. I ostensibly was spending a lot of time with my family, and I was, but a lot of that time was just hacking on fun stuff. So there were more things that I got done in this time. The first one that I really liked was this inflate. Because I was working on this Dino game and I made my own compression algorithm, I thought, actually, it'd be really fun is to make the deflate algorithm, the one that's used inside gzip. So if you look at this demo, basically the way it works is you load up a gzip file, and if I pick one, there we go. Yeah, look how fast that is. Beat that. Infinity speed. But yeah, so this one is actually a pretty cool little demo. Yeah, so like I said, I was inspired to do this when making the Dino game. It's actually based on some of the techniques from a 6502 implementation. You should definitely check out Piotr Fusik's implementation if you ever write 6502 code. I'm not sure a lot of you do, but if you do, it's there. And to better understand it, I actually took his assembler code and then I ported it to JavaScript. So I have an implementation of 6502 that I used to make sure that I could understand how it worked. And this way I could look at the code inside of DevTools to see what was actually happening under the hood. Yeah, there's some details here about how I did that. I won't go into that right now. But one of the cool things you can see here, it's a little bit hard to see, is that the code matches up one-to-one. So on the left here, you can see the JavaScript code. And then on the right here, you can see the actual assembly code. And this way I could check to make sure that it was all doing the exact same thing while I was testing it out. And yeah, so this implementation is also incredibly complicated, so I left myself another giant comment at the top to explain how it all works. One of the coolest things about this, like I said, I did a lot of this because when I was working on demos, it was mostly because I was bored with my work or I was trying to find some joy in the things that I was writing. But it was actually very exciting that somebody saw this and thought, oh, this is actually really useful, and it's faster than the code that's available in JavaScript, so I guess I'll use it. And it turns out that all grouped together, they were able to use 2760 bytes to be able to compress an HTML page down, which I thought was very, very cool. So thanks to them for actually using my wonky software. The next one that I worked on that year was a match 3 game. I won't go into too much detail here, but you can see, like, as you mouse over, it does some cool little zooming effects. Oh man, can you see where the next one is? Let's see. Here we go, poop down. So then you can see it fall, and then, yeah, anyway, I won't play through it all because we don't have time, but this one I actually did for a different talk, the Wasm Summit talk. So if you're curious about the implementation, I go into a lot of details about this. There's a lot of bit shifting and cool tricks to be able to do the analysis. Because it's 8 by 8 and 64 different cells, you can actually use a 64-bit int to do a lot of interesting tricks to do pattern matching and so stuff like that. So take a look if you're curious about that sort of thing. Okay, and so then a little bit after that, I made a Game Boy emulator in 3,000 bytes. This one I'm very, very proud of because this is actually playing a game that I wrote for the Game Boy as well because I needed to have an open source demo so that I didn't have to have Nintendo licensed software. So you can see that as you move around, you can pick up items and so on. It's a full emulator. It doesn't completely play all games, but actually it was based on a Game Boy emulator that I wrote, again, sort of as a code golf exercise that only played Pokemon Blue, and it's shaped in the shape of 3 Pokeballs. This is the C++ source code for it. And so I wrote this in 2021. This is actually how I got my job at Figma. The person who saw this was like, hey, you should come work at Figma. And give a talk about this. And I was like, well, I'll give a talk. And then later, I ended up working there. I also wrote a really long blog post about this, if you're curious about how it's implemented. Way too much detail. Take a shot of the screen if you're curious. So when I wrote this one originally, a couple of people who had been following me about WebAssembly stuff said, oh, I was expecting you to write this in WebAssembly. Kind of disappointed. And so I was like, okay, I guess I'll do it. So then I wrote it. So you can see some of the games working here. Zelda works, Kirby works. This one at the bottom is Mole Mania. It's a really cool game if you've never heard of it before. I don't have a lot of time, so I won't go into too much detail here, but one of the cool tricks was that in C++, you can use macros. Like I said, you can't do that in WebAssembly. So instead, I use a list of masks. So basically, the first one is a mask, the second one is the value to compare it to, and the third one is the value to check to see if it's equivalent, and that's how I do the CPU decoding. Yeah, I don't have time to talk about that. 2022, this is me looking cool because I wrote no cool demos in 2022. I was just working. And then in 2023, oh, that's this year, right. This is me actually lounging. This is not a normal sized bed, in case you're wondering if I'm a giant. I am not. This is a child's bed. Earlier this year, I made a mod demo. Who knows about the mod file format? Yes. Unfortunately, I'm not hooked up to sound, so I don't know if you can hear this, but everybody knows this one, right? Yeah. Yeah. All right. I won't torch you that with. I mean, I love space debris, but you know, we're moving on. So yeah, this is another cool demo. Not a lot of time to talk about it, but I did want to talk about one thing that I made specifically for this talk, because I always like to do something new. This is, of course, Minecraft style demo. Because I was working on a voxel-based game, I figured I might as well make it so that we can play a little Minecraft. So one of the cool things you can do, you can see there's a little bit of shadow here, and if I dig up, you can see that it actually creates a little bit of light there. This is actually based on a really cool demo by, I think his name is Alex Oververd, and it's called Minassemble. And so yeah, you can see this one is also in just 2,700 bytes. Love to talk about this. If you're curious about the details, come and talk to me afterwards. And that's it. I do have a little bit of time left if people want to ask any questions about any of these demos. Yeah, thank you.
If you have a question, raise your hand and I'll come to you with the mic.
Not so much a question as a comment, but you did mention the demo scene a few times. The Doom Fire isn't a Doom Fire. It's a demo scene effect by a Spanish developer, Javier Alvelo from '94. Just a point of order, but it's
that's
really
great.
cool.
No, that's great. Thank you for pointing that out. It's always good to give credit. I want to say a lot of these demos were based on other people's work, and so yeah, thank you to them for making those. It looks like there's more questions.
Hey, I love the tricks with the values and the palette colors and having it be functional stuff. Did you come up with that? Was that something you learned somewhere? How do you get to that? Because that's like just
sweet
insight.
So a lot of these tricks were mostly just me wanting to crank it down a little bit. Actually, the maze demo was the first one that I tried to actually size optimize, and it was mostly just inspired by my now boss at my company, just saying like, 2,500 bytes, can't you make it smaller than that? And I was like, oh, I guess I will. So, you know, what I did was I would just look through the code and I would try and see if there was any way to take some of the values and compress them down. I think there was a talk earlier about how the high frequency coding was putting an individual bit to try and to store a value, and I think that's a lot of what I was trying to do too, just like store a little bit somewhere, try and hide the data wherever I could to compress it down. But yeah, specifically, it's just a lot of just staring at code for long times. Yeah, I think that's all for my time, but thank you so much, everyone.